Oh. Good afternoon. Welcome to the live session of database management systems for this particular episode of NPTEL. My name is Samiran Chattopadhyay. I am from the Department of Information Technology, Chattopadhyay University. I am the co-faculty of this particular course along with Professor Partha of IIT Kharagpur. Today I will take you through this live session for the next 1 hour. As always, we got your questions in your in the Excel sheet for the live session, as well as we have taken certain queries from the forum which were common and which were relevant. We have arranged them under different topics and we have decided to talk about them in a flow of those topics. So, let us start with the first few questions which are basically from the first chapter of DBMS, which is something like importance of DBMS, the drawbacks of DBMS, etc. So, the first query that I have received from the live interactive session was importance of DBMS by Nikhila Sabu, and the answer to that question is it's a very standard and a very long answer, but I will be a little short in it. Actually, before DBMS, more or less these functions were performed by application programs written on top of file management systems. Now, at that point of time, there were many problems in terms of the data that were resident in the file system were redundant, causing inconsistency. Now, access to those data could not be restricted beyond a particular level. Today, we have rollback access control and things like that. Those kind of thing, access control was not available at that point of time. We have views, maybe the same database, but it has different views. Maybe you are a student, you see the database from the student's viewpoint. If I am a teacher, I see the same database from a teacher's viewpoint. The administrator of this particular database will look at it from administration point of view. So, providing multiple user interface or views to the same database is one more important feature that we have incorporated. Data has complex relationships among themselves. To understand these relationships, a mathematical foundation has been formulated, which is known as relational data model as well as relational algebra. Although there are many other different mathematical formalisms, this particular formalism is most important to you at the present moment. So, point is, there is a mathematical formulation, and therefore, this mathematical formulation helps us to optimize design, optimize queries, making them efficient and making them taking less time. We can enforce integrity constraints on a database management system, and we can provide backup and recovery. Basically, I can have fault tolerance as well as secure database. Now, if the question sometimes comes to us, is it not possible to have a file system at the bottom and a very good, very nice application above it to do the same thing as the DBMS does? Of course, yes. DBMS is nothing but a layer of application program written on top of the file system as well as the operating system. So, if you can afford to have a complete Oracle implemented on your file system, it will be the same as the DBMS, but understand the problem of implementing it, the cost of implementing it, and the return that you generate. So, point is, such an application is very difficult to write. On the other hand, we already have such applications written which are known as DBMS, applications like MySQL, Oracle, etc. We can procure them, we can buy them, and we can use them. So, in a nutshell, a standard simple program on top of file system will not be good enough. That particular program will not have all these features, and therefore, we do not have them, we do not use them any longer. We use only DBMS to store data, manipulate data, retrieve data. Now, the next question that I had was database is only used to store large amount of data. Quite right, quite right. Now, if I have let us say a small amount of data, probably I could have used just Excel to store it, and I can manipulate that Excel data using the macros and the formulas and simple programming that Excel provides. We can do that, or the spreadsheet. Excel is Microsoft Excel, but one can use open source spreadsheets as well to do the same thing. Now, for that matter, DBMS is expensive. I mean, it needs a high speed processor, large memory to store the data, to manipulate the data in an efficient manner, and therefore, we have to incur a certain cost. I mean, not a small cost, it is a huge cost, and therefore, if it is something like let us say 500 rows, 1000 rows of 5 such tables, then we will not use a DBMS. We will probably manage to manage that particular data with Excel and things like that. So, only when the amount of data is very large, it is complex, right, then only we use DBMS. I mean, I will tell that the amount of data is not the only factor, the amount of data is one factor, as well as the complex relationship among the data, that is another factor. You have 2 Excel files, if you have to kind of combine these two to manipulate them or to retrieve data, then writing such a program will not be that easy. So, if the relationship among data is very complex, then also we will go for DBMS. Now, one more question was, are there drawbacks of DBMS? Now, you see, I mean DBMS as such will not have any drawback other than DBMS should not be used for a small amount of data, as it incurs cost, it is expensive. As I already have mentioned, it is expensive, you need software, you need hardware for this. Also, it is quite complex in terms of people manipulating it. It involves creating the data, modifying the data, editing the database, and you need skilled staff members to even to manipulate it. Definitely, I mean there are several layers, users is one layer, application programs is another layer, different types of users are there, and except for the naive users, the handling of database will be a little complicated. Of course, you also have to have a database administrator if your database is a little large. So, I would not say that these are drawbacks. Frankly speaking, I do not know of real drawbacks of a DBMS, but if the data is seriously small and it is quite flat, not much of complex relationships present in the database, in the data, then you can go for storing them in flat files or spreadsheets, whatever is available to you. Otherwise, you have to go to DBMS. Now, we will go to some questions or some important concepts which we have found out either in the live questionnaire or in the forum queries. Now, we have seen that these terms table, schema, relation, tuple, row, instance are being confused by the students. I mean the students confuse these terms. Now remember that in a relational database we have relational algebra, on top of that we have relational data model, and then that relational data model is implemented in terms of relational database. Now, these 3 different concepts use separate terms. For example, take the term table. In relational algebra or relational data model, we call them relations, and in DBMS we call them tables. Now, a table basically stores information about one entity, one table, and at certain points of time relationships themselves. Now, naturally a table has rows, it is a 2-dimensional table, it has rows, number of rows, and it has a number of columns. Now, every row except the header row represent a record, and columns represent the attributes of that particular record. Now, therefore, if you compare this table with relational algebra, they are the same. So, in DBMS we call it table, in relational algebra or relational data model we call them relations. What about tuple as I said, a table has different rows, every row is a record as far as a file is concerned, and in RDBMS every row is called a simple row, but in relational algebra it is called a tuple. Now, tuple in relational algebra is the same as table in relational database, and record in the parlance of file systems. They are the same thing. Now, what is an instance? We have an example after this slide, we will talk about it in detail. Now, at a given point of time for a particular table, the table is filled up with data, right. Now, that is called instance for that particular relation or contents of that particular table, again the same thing. And what is a schema for a relation? A relational schema is nothing but the name of the relation along with the attributes and their names, right. Formally, I mean being very more formal, I would say that every attribute also has a domain. I mean if I say it is a roll number, it is a numeric value, it has a domain of integers from some minus infinity to plus infinity, some max number to some min number, and so on. Now, let us go to the next slide where you can find out a table. Look at the table. The table has a header if you look at it. Weeks completed, current assignment, total score. Now, this weeks completed, current assignment, total score, individually these are 3 attributes, right. The current, the header of this table, weeks completed, current assignment and total score, these are attributes of a relation. I may call the name of the relation is DBMS, right. So, the name of the relation is DBMS with 3 attributes, weeks completed, current assignment and total score. So, just the header gives me the names of the attributes as well as the name, the schema of the relation. It is called the relational schema, and the content herein, like first weeks is completed, current assignment is assignment number 1, the total score that you have obtained maybe is for 20. Number of weeks completed is 2, the assignment that is currently live is assignment number 2, and the total score that you might have obtained is 43. Now, weeks completed is 3, the current assignment that is available to you is 3, and your total score is 48. So, at this point of time, this is the instance of the database of this particular table. This is the instance of this particular table. Now, in a database there will be 500, 600 such tables. At a given time, the contents of all these tables will become the instance of that particular database, right. And what is schema? Do not confuse it with the relational schema or relation schema that we have talked about in the earlier slide. One relational schema is the header of the table for one relation. Now, what is database? This is basically database schema. Now, what is database schema? Database schema is the collection of the relational schema for all relations, for all tables of a particular database. One database does not contain in real life only one relation or only one table, right. One database comprises 100 tables or 100 relations. What is its schema? The schema of 100 such relations or the header columns, I mean header row of 100 these tables constitute the database schema, right. And the instance is the collection of the content of these 100 tables or the 100 schema, relational schema is the instance of a particular database at a point of time. Now, for example, you see the in week 1 maybe the table at the top, right, or at the middle, that is the instance of one particular table. In the same table after the week 2 we will have one more record added to it. So, after week 2 the instance of that particular table will be 3 columns with 3 rows with one header row. So, see instance will change with time. Once you add rows, instance will grow, once you delete rows, instance will shrink, right. Now, we have seen certain questions on keys, candidate key, primary key, super key. So, given a relation R, let us say that K is a set of attributes, not the whole set of attributes, maybe a part of that. Now, K is called a super key if the values of K are sufficient to identify a tuple uniquely in R, right. Now, if K is minimal, K is a candidate key, and any candidate key can be chosen as the principal key or as the primary key to identify tuples in a given relation or in a given table. Let us go to the example, it will be easier. Look at this instance of employee. What is this? Employee table, employee number is there, employee name is there, job, manager and date of hiring, these are there. Now, in this employee relation, I am told that employee name is unique in each record, in each row. I am also told that employee number is also unique in every row. Then I can say that the super keys could be ename or emp number or any set of attributes which contain these minimal keys, ename or emp number. So, it could be ename and emp number, it could be ename and job, it could be emp number and job, it could be emp number, ename and job, and so on and so forth. But what are the candidate keys? Only two candidate keys. What are those candidate keys? Ename and emp number. Why not more? Because a candidate key has to be a minimal super key. Look at this example. There are many super keys. What is the minimal super key? The super key is with minimum number of attributes. In this case, there are two super keys which have only one attribute in themselves, and therefore the candidate key cannot have more than one attribute. And which are those attributes? Ename or employee number. Why not anything else? Because they are not unique in all records. There could be many clerks in this particular organization, there could be many managers in this particular organization, there could be many salesmen in this particular organization, right. Now, if there are two candidate keys, which one should be chosen as a primary key? Any one of them, But if you ask me, I will tell you, take employee number. Why? Employee number will be a numeric field, it is an integer, and therefore, to store integers, space is optimized. To manipulate them, we can do that easily, and therefore, primary keys are preferably numerics or numerical. Now, a key which has more than one attribute is called a composite key. Like for example, a student relation which have student name, student email, subject ID and rank, we call the student name and the student email together is the primary key. Why? Must we have told that the student name may be overlapping, maybe there are two students with the same name, and even the student email may be non-unique among different students, but student name and student email together are unique. Who tells me that? The problem domain tells me that. Whoever has asked me to write this particular relations or this particular tables, they tell us what is unique and what is non-unique across records. Accordingly, we build this particular keys. Now, for example, if there is a subject relation, then maybe there are two attributes, subject ID and subject name. Now, subject ID is unique. So, therefore, subject ID is the primary key, but it is not a composite key. Why not? Because subject ID is only one attribute, the key primary key contains only one attribute. Similarly, faculty relation may have just faculty ID as well as faculty name. Now, this also is not a composite key, because faculty ID is just one single attribute. But if you look at subject faculty kind of a relation, where subject ID and faculty ID both are present, then subject ID faculty ID is the primary key, I am told about that, but I see that this faculty ID is a foreign key in subject subfac table relation. Faculty ID is a foreign key because it is a primary key to the faculty relation. Similarly, subject ID is the primary key to the subject relation, and therefore, this is also composite key, but this is a special kind of a composite key where individual attributes are foreign keys to other relations, and therefore, we call such composite keys as compound keys. So, compound key is necessarily a composite key, but the attributes of the composite key actually become the foreign keys to other relations. Okay. Let us go to some other question. Yes, the question was, can two attributes be a primary key? I have already answered that two or more attributes together can form a primary key. These keys are either compound keys or composite keys in nature. Similarly, one more question was there, and that was, if this is an instance, somebody was saying that if this is an instance, if I assume that Aadhaar number is available to all students and Aadhaar number is unique in a particular country, then Aadhaar number can be a candidate key. Aadhaar number is definitely a candidate key because it uniquely identifies every record, every row of this particular table. But in case I am told that there will be some students where Aadhaar key may not be available, what does that mean? This Aadhaar number column may have null values, then I cannot take Aadhaar number as a candidate key, because to become a key, two criteria must be satisfied. One is, it has to be unique in all records, in all rows, and the second one is, it must be non null. Any column which has null values cannot be a candidate key or a primary key, right. I think this is the answer to your question, that passport number cannot be a key. Now, passport number may not be available to all people of a particular country, because all of them may not have passports. Now, therefore, if I think about the column passport number, there would be null values, and as I said, candidate keys or primary keys cannot have null values in their as a proper value, because they cannot identify the tuple uniquely, right. I think this is more or less understood. Now, someone, Monisha Runjun, asked us, showing this diagram at the very second column, last row, there is a teaches, there is a rectangle named teaches, and the question is teaches a key? Now, first of all, what is this diagram? This diagram is not in ER diagram, this diagram is called a schema diagram. Now, what are these rectangles? Each of these rectangles are nothing but table names, relations, and what are the content of these rectangles? These are the attributes of that particular rectangle, and the underlined attributes basically constitute the primary key for that particular table, right. Now, as you understand, this teaches is nothing but a table, and this teaches has a primary key which is constituted by ID, course ID, section ID, semester and year, and this ID is a foreign key of instructor, course ID, section ID, semester and year are constitute the foreign key of the entity of the table called section. This is what this particular diagram means. Now, if you think about it, this teaches is nothing but a relation in the ER diagram. It must be relation in the ER diagram, where one instructor can teach in many sections. Similarly, one section is taught by many instructors, right. Now, this is a many to many relationship. To realize this many to many relationship, that the relation is actually implemented in terms of one table by taking the primary keys of the different entities among which this relation is built, right. So, this is so there is no question of this thesis to be a key of anything. Now, another question on primary key is a surrogate key, nice question. Surrogate key is an external key or is an artificial key, no doubt about that. Now, take this example, it contains names of people who worked in a project for a particular duration, start date and end date. Now, Rahul may have worked in project T flight, may have worked in another project as well. So, Rahul, the name Rahul will not be unique in this particular table. At this instance, it is unique, but maybe at a different point of time, the name Rahul will not be unique. Similarly, the project T flight may have many persons working in it, maybe Rahul has worked on it, maybe another person has also worked in it, meaning E project, E flight is not unique in the different records of this particular in the records of this particular table or in different rows of this particular table. Maybe the start date is the start date of many people in different projects, and end time is also the same for many people in different projects, right. So, what I mean is none of these attributes even taken together maybe will constitute a primary key. So, in this example I have to import an artificial column, artificial attribute for the primary key. Now, so therefore, I need the concept of a surrogate key for this. Sometimes we find that the problem, I have a primary key, but the primary key may be 5 attribute long and maybe the size of the primary key, let us say, is 1000 byte. Now, 1000 byte long primary key is very performance inefficient. We do not like such long primary keys. Even in those cases, we would like to have external artificial keys, so that the performance of different queries on that particular table becomes efficient, right. So, surrogate keys are important for two purposes. One, primary key is not available from the problem domain, or primary key is available, but it is non-numeric and very large. In these two situations, we actually use surrogate keys or external keys. Okay. Now, joins, it is a question on join. Now, the question is why joins are used. You know all that there are different types of joins: natural join, equijoin, outer join. Outer joins are of 3 types: left outer join, right outer join and full outer join. The question is probably not what they are, but the question is give some examples where we use them. So, I have an example where I will tell you what to do, why do I need these joins. Say that I have a table called loan, the loan numbers are there, branch in which the loan is taken is there, the amount of loan is there. Also have an account holder in the bank, in the financial institution. I hope that they will have accounts. Now, the customer name is there and the loan number is there. Also, we should know that all customers do not take loans, and similarly anybody who takes loans in that particular bank will not have accounts in that particular bank, right. Now, I want to know those who took loans, what are the names of those persons, if they have accounts as well, right. Or I may like to know though the account holders of this particular bank, if they have loans, what are the amounts of those loans. These questions I will ask. So, I have natural join to tell me that the account holders in this particular bank, the details of those people who have loans in this particular bank. So, I can either do a natural join or an equijoin. Basically, natural join is better because natural join and equijoin has the same content, same information. Only thing, natural join has less number of columns, because the loan number for loan dot loan number and the account holder dot loan number, they are the same thing and they are not duplicated in the table. Only one column for them is allocated in this particular table, and therefore, the natural join is good. But if you look at the left outer join, you see that the loans which are taken in this particular bank, details of those loans I can see the customer names of those loans, of those loan takers, the borrowers. I can see them if I do a left outer join, and of course, there is a loan which was taken by some person, the number is L-260, and for that particular person I do not know the customer name, because the person is not an account holder in that particular bank, right. So, similarly, if I do a right outer join, I will find out that the account holders who do not have a loan at all. For example, Hayes here, who does not have an amount, amount is null, he has an account, but he does not have a loan. So, if I want to know which customers did not have a loan, I can do a right outer join, and if I want to know all information about the loan accounts as well as the account holders, then I do a full outer join, right. In this case, I find out that account holders in this customer, in this bank, are 3, Jones, Smith and Hayes. Out of them, Hayes does not have any loan, and there are 3 loans in this particular bank, out of which the loan number L-260 does not have an account in this particular branch, in this particular bank. So, I can get more information about the loan, about these 2 tables, and I do this outer join, right. Now, the difference between car and varchar I will tell, but ID should be numeric, and ID should be, IB could be numeric, no doubt about it, but at many points of time ID contains letters as well. Like for example, let us say there is an office where IDs are M1, M2, M5, E1, E2, E3, E4 like that, and where M means managers, E means engineers, you can very easily see that ID is not numeric in this case, it is alphanumeric. So, ID should be string instead of numeric in these cases. What it will be depends on the problem statement. The way the problem statement is given, you have to identify what will be the type of that particular attribute. Now, car and varchar, the difference is basically car n is a fixed length character like an array, the length is n. Now, even if you have let us say you have declared a car 5 and you are storing just high. So, you are storing only 2 characters, but the remaining 3 characters are padded with some stuff, but the length of that particular attribute or the variable will be 5. In varchar, it is a variable level character, variable length character whose maximum length is n, right. But so, if you say it is a varchar of 5 and store high, the length of high would be only 2, not 5, right. So, we prefer to use varchar instead of car to save space. Now, the second, the next question is on order by. Order by is really sorting in ascending order or in descending order of a particular attribute depending on its type. Now, the question is, I am saying order by B and C in this particular example, B and C. Now, how can it simultaneously order it on B and C? It does not do a simultaneous ordering, it does a sequential ordering. It first orders in B, like it is A1, A2, A3, similar thing is A1, A2, A3, but inside A1 if there are multiple rows, if A1 has multiple rows, then those rows will be sorted in the alphabetical order of C. Like for example, there are 2 records with A3, one is Anup and one is Anand. Now, Anand is lexicographically smaller than Anup, therefore, the output in this particular query would be A3 Anand and then A3 Anup, right. It is similar to kind of look up in a dictionary where if I have 2 words left and leaf, right, then leaf will come before left, right, but leaf and left will come much before mankind, because mankind starts with M, right. So, it is sequential ordering, first you order in B in this example. Now, once it is ordered in B, then for the same value of B, if there are multiple records, order them in the in the ascending order of C. That is the way we do it. Okay, now, this is quite interesting. The question here is that there are multiple examples with multiple queries given. Now, maybe the relation or the table is also table columns are also given, but how can I create a data, appropriate data, how can I fill up the data for that particular database. Like for example, if I am given this question, the question is the best in category award list is prepared as follows. Suppose that there is a relation online magazine with columns article number, creator, volume and article type. Now, I want to find out those article number, creator and volume, right, and article type should be selected where the views is highest in each category of article type. Now, this article type attribute should be renamed as best in category in the output, right. So, article number, creator, volume and article type is there. Now, maybe the same article type repeats in different rows, right. Now, in different rows the article type remains the same, but the views, the volume may remain, volume may be different, volume may be, I mean volume may be 5 in one record, volume may be 10 in another record. Now, I want those tuples where for given article type the volume is the highest, right. Now, and then ultimately this article type attribute should be renamed as best in category. Now, first thing what I will do is I will create a table, empty table with the name online magazine and the columns article number, creator, volume, article type and views, correct, 5 columns. Now, I arbitrarily write down article number P1, P2, S1, I generally write down them. Only thing only thing interesting here is I will have to give different article types and I will have overlaps, like painting may be twice, story may be twice, recipe may be twice, painting may be 4 times, and I am changing the views is 486 in one. For the same painting views would be sometimes 486, sometimes 400, sometimes 900, sometimes 5000, sometimes 5000. Now, which one has the highest view? 5000, the record with the 5000 views for painting. For story, what is the highest view? 2895. So, I have to create this table in such a manner that for the same article type the views will be different, and the question there is pick up those records where views for a given article type is maximum, right. So, what should I do? I mean how do I get to a solution? To get to a solution, I first group by this online magazine by article type. The moment I group by, then all the painting records with the painting article type will come together. So, with painting there are 4 records, all these 4 records will come together. With story there are 2 records that will come together. With recipe there are 2 records that will come together. The moment they will come together, then what I can do, I have got them together by group by, then I select max views in these groups. The moment I select max views, this aggregate function will give me only those records where the views is the maximum, and therefore, I will get these three rows, article number, creator, volume and best in category. You see that best in category is the new thing, right, because the question was change the article type column name to best in category. How did I do that? I did that by, if you look at it, by as keyword. I said select article number, creator, volume, article type as best in category. So, basically I said that when you prepare the output, you rename the article type column name by the best in category name, and that is what has been done in the output, right. So, what is the what is that I wanted to tell you? I wanted to tell you that when you get such a question, you look at what the relation is. The relation is a little, I mean, there is a mistake in the relation name. It has 5 attributes, not 4: article number, creator, volume, article type and views. And the question was, for a given article type, find out the largest view in a largest view and report that particular view in your output. That was the question, and not only that, change the column name article type to best in category, right. So, that was what the question, and therefore, I created this particular table, kind of from imagination. I imagined from the question, I got a hint that there will be many records with the same article type in this table. Therefore, I have many article type, many rows with the same article type, and the views I had different numbers, right. And the question said, given an article type, find out the record with the largest views. They have been highlighted by red color in this particular table. Once you do that, you go to the solution, you try to find out the SQL query. In this SQL, I mean, all these examples contain nested SQL queries. Therefore, the inner query has been highlighted in blue color in all of them. Let us look at the second example. Assume that there is a relation authentication technique and the attributes are authentication ID, AID, authentication type, A type, access to whom access is granted. These are the 3 different attributes, right. And the question is, select the tuples, select the records where the same A type, what is the type? Access type, same access type is not assigned to different groups of employees. What does it mean? It means access type could be fingerprint, access type could be retina, access type could be password, right, access type could be PIN, right. Now, different access types are these. Now, the same access type, I mean let us say the access type is fingerprint. Now, different users, who are the different users? Maybe manager, employee, etc., etc. Now, the same access type, meaning let us say if I assign fingerprint to manager as well as employee, then it says that do not report such tuples, report only those tuples where the access type is assigned to distinct access tools, right. And the other question is just the opposite. Find out the records where the same one group of employee is not provided with different access type. So, I understand that the access type will have to be different and access to will have to be different, and the same access type will occur in many records and same access to will occur in many records. Exactly that is what we have done. We have said fingerprint, face, PIN, password are different access types. I have in many records I have said fingerprint is used doubly, his password is used doubly. Employee access is a group of user, employee is duplicated in 2 rows, manager is duplicated in 2 rows, things like that. The first query says one A type should not be given to different groups. In this example, therefore, you see password is one access type which is given to managers as well as employees. So, these particular rows should be excluded in my output, right. So, what I should do now, therefore, what I should do is I have to this is a very standard technique. I have to create 2 instances of this same table. How do I do that? By as keyword. Look at the inner query first. Select all these attributes from authentication technique table as A and as B. So, the same table is duplicated A and B. Now, what I am doing? I am doing A cross B, a multiplication, right, where A dot A type is B dot A type, A types are matching, AIDs are matching, but A dot access to is not matching with B dot access to. If I do that, what will happen? I will only get the last 2 rows, password manager and password employee, right. And therefore, when I get them, password manager and password employee, now what my outer query says? My outer query says that select start from authentication technique except. So, it is except means a minus operation, just a minus operation. So, this table minus whatever you have got, I have this table. Now, inner query gives me the last 2 rows. So, the original table minus the newly obtained table which contains the last 2 rows, I do a minus. What I get? I get simply the first 3 rows. So, that is exactly what I have got. So, when you come to an inner query, a nested query, understand the inner query has to be evaluated first, and a temporary table or a temporary column or a either a temporary column or a temporary table will be generated, and then the outer query will be fired as if the outer query's input is the result of the inner query. The inner query's result will serve as the input to the outer query. The same thing, I mean, for the second query, if you think about it, it was said that access to I mean the group of users should not have different A types, right, and the question there was so that manager had a face access type as well as a password access type, and similarly employee had probably a fingerprint A type as well as a password A type. So, only technicians was the only group of users for whom only one type of access was provided, which was PIN. So, that only that particular row should come. We are if you work with if you take this as a homework and find out the output of the inner query and then use that inner query's output to the as the input of the outer query, if you do that, then you will get this output. I urge you to do that, and if you get into difficulties, ask us in forum about the working of that particular SQL queries. Now, the same question actually came again, that I have the queries, I have the questions, how 2 questions actually in it, how to frame the content of the tables. So, that is why I have shown you 2 examples in which the question was given to you at the beginning. The question also told you what the table is, and then it was given and then I actually tried to populate those 2 tables, getting clues from the question. Now, what were the clues? The clues were which columns are to be duplicated in different rows, right. If there are certain columns, if there are certain columns whose values are to be duplicated in several rows, those clues will be available in the question. Take those clues and then populate the table according to that. Now, whether you say A type is fingerprint or face or password does not make any difference. You can say A type is A1, A type is A2, A type is A3, does not matter, but the question says there are same A type may be given to different access to people. So, if A1 is your A type, then try to give A1, try to put A1 in different records. And the other question was different groups of users which is indicated by access to column, they may have different access types. So, what should you do? If you say access to, the value of access to is A21, A22, A23, then have in your table several rows whose column value is A21 in access to under access to column, A21, A22, A23, and then look at the problem and find out from the problem what should be your sample output, right. If you see that the output comes to null, then try to change the table so that output, I mean there is at least one row as the output, right. So, play with the content of the table without thinking about what the SQL query will become. Do not look at what SQL query will become. Now, for example, if these are the different questions, right, then find out See, you can find out, for example, you can find out that exam routine is a table, right. Of course, because it is from exam routine, right. Now, from step counter, so step counter will be a table. Now, also from different attributes used in the question, you can figure out that these are the attributes which are mentioned in exam routine table as well as step counter table, and then you frame these questions, right, these tables put content in these tables. Somebody asked me about 10.11 and 10.12, Ankur 14, and the question is basically about referential integrity and the foreign key, concept of foreign key. So, I chose to use an example to talk about it, a question about it. I will show you an example here. Look at the customer table and the contact table. You see that the customer's first name is Elaine, last name is Stevens, and customer ID is 101, and the contact information of 101 is stored in another table which is contact. 101 contact information is, it has a phone number as well as a contact type. So, maybe it has 4 types of contact type, 3, it may have a work contact, it may have an email contact, it may have a home contact, it may have a fax contact. So, there are several types of contacts for 101, 102, etc. Now, the customer ID in the contact table is a foreign key. So, it points to the primary key of the customer table. And you need to understand that if I use a customer ID in the contact table, then that customer ID must be present in the customer table as a customer ID, right. So, if I have customer ID at a given point of time as 101, 102 to 105, and I all on a sudden write the contact of customer ID 106, that will be wrong. Why? Because 106 customer ID is not present in my customer table, that is the parent table, and this is the child table. A child table which references, right, to a parent table must ensure that if it has a foreign key column filled up, that foreign key must be present as a primary key in the parent table. More precisely, you see that the parent is department and child is employee. So, employee King works as a president in the department 10, which is department of accounting, and the location is New York. Now, all on a sudden I want to store, just let us say I want to store Ford as a manager in that particular organization whose employee ID is 9. Now, I insert it into the child table, the employee table. Does the parent have any primary key 9? No, it does not, and therefore, that is a violation, that is a integrity violation, referential integrity violation. I cannot do that. What can I do? I can store department number as null for the time being, then I can store the department with department number 9 in the parent table, and then I can fill up the department number for Ford, which is in the who is a manager in that particular company. So, before I insert 9 in that particular record for Ford, I must have a 9 inserted in the parent table as department number and have the department name and the location in that particular table, right. So, I can insert a foreign key null, but I cannot insert a foreign key which is not present as a primary key in the parent table. That is the integrity constraint that we have. Now, if you think about it, the question 10.12 slide has a very interesting thing. The parent table and the child table are the same table. The same table is used as the parent table and the child table, but the concept that I have talked about now holds there as well. So, if you want to put some person in that particular child table, which is the same table, now the mother of, and say someone is the mother, then the mother's record must have been present. What is the other way to do that? You put the mother's, in the foreign key, you put it as null and go ahead. Later on, add add the mother's name, mother ID, and use that mother's name and mother ID as the foreign key, I mean to edit the data in the given table, that you can do. Multimedia data is stored as blob in our DBMS, and semi structured data and unstructured data cannot be stored in relational data model. For them we have NoSQL databases. There are many types of NoSQL databases, and it by itself is a different type of different course. So, this much you know that semi structured and unstructured data cannot be stored in relational data model as such, they are stored in NoSQL databases. Now, functional dependency, we have for the same relation, for the same table, I may have two sets of functional dependency, and sometimes those two functional dependency sets are the same, logically the same, right, but syntactically they may be different. Now, what I mean the question, if the question is how do I know that they are equivalent, they are the same, they are syntactically not the same, the LHS is not the same, RHS is not the same, right. But then what I mean by they are the same, by saying that they are same, they are equivalent, we mean that all the FDs in F can be derived from the FDs in G. If there are two sets F and G for the same table, for the same database. Now, if all the FDs in F can be derived from FDs in G, then I say F is subset of G, and if all FDs in G can be derived from all FDs in F, then we say that G is a subset of F. Naturally, if F is a subset of G and G is a subset of F, then F is equivalent to G. So, if you take this example, standard example actually, F is A determines C, AC determines D, E determines AD, E determines H, 4 FDs, and G is A determines CD and E determines H, 2 FDs. Now, what you do, you try to find out closure of left hand sides of F, but using the rules of G, right. So, you do A plus using the rules of G, right, A plus, AC plus, E plus. Why A plus, AC plus, E plus? A is in the LHS, AC is in the LHS, E is in the LHS of F. Similarly, you do in G LHS closures A plus, E plus, right. Now, and then if you see A plus is the same from the set of G as well as from the set of F, then F is a subset of G, right. Similarly, if you do closures of G with the rules of F and find out that the LHS closures are the same in both cases, then G is a subset of F, and then F and G are equivalent, that is what it is. So, I have one more interesting topic, which is aggregation. I just stop by saying this, that relationship in here is nothing but relationship between two entities, but when I have relationship between one relation and one entity, one or between two relationships, then ER diagram does not give me a tool, and for that I use aggregation. We have an example here, but I am running short of time. So, I have to stop here. Thank you very much for your attention, and I hope that you enjoyed this class, and if you have any queries or questions, post them in forum, we will be happy to answer that. Thank you very much.